In this video, we're going to look at acid-base reactions. An acid-base reaction is simply a base plus an acid making salt water. And this is also called neutralization reactions because both of these substances are becoming neutral when it becomes water. In an acid and base reaction, you can also get gas evolution reaction where we form gas, and we'll talk about that in a few minutes here. But before we start, we have to define what an acid and a base is. And there's a few definitions, but we're going to start with the Arrhenius definition. And that is, an acid produces H plus in water. So let's look at a hydrochloric acid. That forms a H plus Cl minus when it's in water. However, H plus really doesn't exist in reality. What happens is this hydrogen atom interacts with this H2O plus to make what's called a hydronium ion. And a base is something that produces OH minus in water. So we have sodium hydroxide, and that goes to sodium plus hydroxide, a hydroxide ion. And this OH minus actually does exist in reality. Now, acids can have more than one acidic hydrogen. And if it has more than one acidic hydrogen, we call these polyprotic acids because they release more than one H+. So let's look at sulfuric acid. We can see there's two hydrogens here, so it is called a diprotic acid. While phosphoric acid has three hydrogens here, so we call that a triprotic acid. And in reality, you don't go higher than a triprotic acid. You either are monoprotic, diprotic, or triprotic. In general, when an acid and base reacts, we make water plus salt water. And so let's look at an example here of hydrofluoric acid plus sodium hydroxide making water and sodium fluoride, salt water. So that's a molecular equation. Let's see how this actually works. So we're going to write the complete ionic equation where we have H plus F minus plus Na plus OH minus. And remember, water is a liquid. You do not separate solids and liquids when you're writing ionic equations, so it stays at H2O plus Na plus F minus. Our next step is to write the net ionic equation, so we're going to do that by canceling out everything that occurs as a reactant and product. And we get that H plus OH minus goes to H2O plus. This F minus is a typo and it should be gone. So it's just H plus OH minus goes to H2O. So really, an acid-base reaction, all you're doing is you're combining H plus acid plus OH minus to make water. That's what an acid-base reaction is. You're making water. And the way we do this in lab is called a titration. You'll actually be doing this in lab if you haven't already. And what you do is that you have a base and you have an acid. Usually what's in this flask is an unknown concentration, and what's being titrated is a known concentration. And the idea is you're trying to figure out, okay, what concentration of acid do I have? And you watch that through what's called an indicator. Now, an indicator will change color based on the pH. And we haven't gone over pH yet. So a crash course. pH of 7 is neutral. Below 7 is acidic. Above 7 is basic. And so what will happen is that once this goes above neutral, that is, you have used all your acid, this will turn pink, meaning the amount of base and acid, the mole to mole ratio has been reached, that are they're equal. And then through calculations by watching how many milliliters has been used, you can figure out what the concentration of this acid was. And like I said, this is something that you will be doing in lab. Now let's actually try and do a titration calculation here though. So you have 10 milliliters of HCl and you do not know what its molarity is. But you do know that if you add 12.54 milliliters of 0.1 molar NaOH, you can reach the equivalence point. That is, the molarity of HCl would equal the molarity of NaOH. Therefore, what is the concentration of this unknown HCl solution in molarity? Take a minute, try to figure it out. If you're completely lost, you can go to your book, but please come back when you have an answer. Alright, let's see how we solve this problem. So I'm just going to go through the steps of solving it. So 1, write down what reaction's happening. You have HCl plus NaOH making water and salt. 2, what are your knowns and unknowns for this? Well, we know the amount of HCl we're using. We know the amount of NaOH we're using. We know the molarity of NaOH. We know the molarity of NaOH, but we don't know the molarity of HCl. So what's your goal? Our goal is to determine our unknown. How are we going to do this? Well, we're going to use M1V1 equals M2V2. So we're going to say M1 is the molarity of HCl. We don't know that. V1 is the volume of HCl. We do know that. M2 is the molarity of NaOH. We know that. V2 is the volume of NaOH. We do know that. So we just solve for M1 and we get 0.215 molarity. You could also use the train track method to solve this. In fact, I would encourage you to do that when you're working with diprotic and triprotic acids, because this M1V1, M2V2 doesn't quite work when you're using diprotic and triprotic acids. And there you want to use the train track method, which I hope everyone is familiar with by this time in the course. But for monoprotic acid, you can use the dilution equation for titrations. Now, sometimes when we mix an acid and a base, what will happen is that we'll form gas bubbles. As shown here, we have NaHCO3 plus HCl, base, acid. When we mix this together, we'll get water, sodium chloride, and CO2 gas. And this gas will come out of solution as bubbles. Now, what can actually happen is that maybe our product isn't directly a gas, but it creates an intermediate. So what actually happens in this reaction, we make H2CO3. We don't make CO2 directly, but this H2CO3 immediately breaks down into CO2 gas and H2O. But for this course, it's just, you should be aware that you can create gas during an acid and base reaction. And so let's look at what will actually form gases. So if you have sulfides, you'll make H2S. If you have CO2, that's the type of gas you'll make, and the intermediate is H2CO3. For sulfites and bisulfites, the intermediary is H2SO3 to make SO2. And you can also make ammonia by making NH4OH. So when you're solving acid-base problems and you're switching your metals around, if you get one of these intermediate products, you know that you're going to make a gas. It's going to break down to that in water. That is something to be aware of. All right. So let's do a little practice with acid and base. Simple problem. But please complete and balance this acid-base equation. Pause it and restart the video when you have an answer. Okay. So the first thing you want to do is figure out what is the acid and what's the base. So this has OH in it, so that's going to be your base, while this has hydrogens in front. That's going to be your acid. And you just switch around. Here, you put your metal over here, your calcium, while your H2 is going to be with OH to form water. So you're going to form 2 H2O plus CaSO4, and it's a solid because you need to look at your solubility tables. And it's also balanced. So all these stuff would be graded in a test where I would see, do you have the states right? Do you have your balance right? Do you know which one's your acid and which one's your base? So you're going to want to do practice with that if you're still unsure. Okay, that's it for this video. See you in the next.